All right, so let's talk about this backup power lab. Yeah, it's a pretty cool lab where essentially what's going on is that we're designing a system to be able to have backup air pressure in case there's an air pressure failure and or a power failure and or maybe there's an air pressure failure because there's a power failure, or maybe for some reason the compressor just died and we have lost power. But it's really very important that we still have at least one action of our pneumatic cylinder, maybe two. We can design it to have two if we wanted. Right now we're just designing it to have one, maybe two, but essentially what's going on is that there's a latch on the deck of a ship, and it's a heavy latch, and there's a pneumatic cylinder that can open it. Now it opens and closes, and that's fine. There's this pneumatic cylinder that is used with a lever. There's a lever that's controlling the pneumatic cylinder, and if anyone wants to access this heavy latch or the heavy port on the deck of a ship, what's going on is that there's an assistive pneumatic actuator. So they just move the lever and it goes up, and then they move the lever and it goes down again. Now we're going to add some safety as well here, because we know there could be like a runaway load, something could fail. So we're going to put a pilot operated check valve in here to deal with some safety. But the focus of this lab is to figure out how we can use a shuttle valve and an accumulator or a backup air supply to allow us to, if the power goes out, if the air dies, open that hatch one more time. Okay, here we go. So let's take a look at the lab. So here we go. Here's all this equipment here. Let's just run through this and see what's going on. Essentially, we've got this heavy hatch here that's got to be lifted. And we have an actuator system that's a pneumatic actuator with a lever, and we can move the lever on a DCV and control the hatch. So it's really heavy, and it's important that we have that extra help. What happens if the power goes out? Essentially, what we're going to do is we're going to deal with the power going out next. But right now, I just want to say, hey, just for safety, in case the DCV dies or in case anything in the system dies, what we're going to do is we're going to put a pilot operated check valve actually directly connected right into the actual cylinder. This is not a pilot operated check valve, but it's the closest thing that I have. And what it is, it's threaded right here. So it goes actually right into the cylinder. And there's a port here. A pilot operated check valve would actually have another port coming out of it that would go in. So this is going to be right at the cylinder. So if anything fails after this, if the line from the cylinder to the DCV fails, or if the DCV fails, the air can just vent out and that cylinder can drop, and that big heavy door is going to come down possibly on somebody's head. So we're going to put a pilot operated check valve in there for safety. And now what we're going to do is take a look at this air backup. Okay, so I've got this cool circuit here. I've built it in Automation Studio. The purpose and function of this whole lab is for you to build this in Automation Studio. So let's actually take a look at what's going on over here. So we've got this guy and I've got a DCV here with a lever on it. I've got this accumulator, so it's lifting the hatch up and down. I've got a bunch of other stuff in here. Before I even talk about the backup air supply, I want to introduce to you a compressor and a tank. Yeah, we're going to study compressors a little bit later, but right now I just want to give you kind of your first look at how this actually works. Here we go. There's our compressor and there's our supply tank. In the discussion below, we're going to see how we're going to put the settings on this. We're actually going to set the volume of this tank. We're going to set some attributes to this compressor. So there's also another compressor. There's another compressor up here, which is our compressor 2. It's our backup compressor. And there's also a pressure regulator here. And sorry, I forgot to talk about this pressure regulator. There's a pressure regulator here as well. And there's an accumulator here. So this accumulator is just kind of like a small air tank. It's just going to have enough pressurized air. It's going to store enough pressurized air. It's kind of like a backup battery that's just going to allow this cylinder to extend one time to lift that heavy latch. So there's a bunch of valves in here, and I'll explain those and how they kind of work as I demonstrate this to you in Automation Studio. Just bear with me for a sec. Let's take a look at this shuttle valve. Now, we've studied shuttle valves, but we didn't really get into applications so much, or we didn't talk about them a lot. So here you go. Welcome to the concept of a shuttle valve. What a shuttle valve is we have air coming in from one side, air coming in from another side, and then air coming out. the air that goes out will come from whichever side has higher pressure. So for instance, if I were to say, this is a gauge, by the way. So if gauge 3 says, say, 80 psi, and this gauge over here, gauge 1 says 70 psi, then I'd have 70 psi over on this side of the shuttle valve, and I'd have 80 psi over on this side of the shuttle valve. So therefore, the air from here would win, it would come up, and my gauge 4 would actually say 80 psi, because it's getting air directly from here. If, for some reason, my main air supply died, so this regulator got broken, or maybe my tank blew a hole in it, and or this line broke down, or this line broke down, or my compressor actually died because I've just lost power somehow, and all the air is vented out there, all that pressurized air is vented out, what am I going to do? That latch is so heavy, I'm going to need like 2 or 3 people to lift it up. So I'm going to have a backup air supply. What I'm going to do is I'm going to turn this valve here. These are just shut-off valves. These are ball valves. These are just on or off. They allow air to flow or not to flow. There's no in between. What I'm going to do is I'm going to turn this on or make it open. So now my pressurized air from my accumulator is going to come in here. It's going to go to the shuttle valve, and because of this side, I've lost all my air. There's no pressure over here. So the shuttle valve is going to move over, and now the air will come up here, and this guy is now going to reach 70 psi. I can then move my DCV, and I can make this cylinder go up and down. So what you're going to do is, when you build your automation studio, and I'm going to show you kind of how to do that in bits, not entirely, you're going to go in your compressor and you're going to set these levels. You're going to also go into your compressor 2, set these levels. We've also got a pressure tank, our main pressure tank, this guy over here. You're going to go in there and set its volume to 0.5 cubic foot. It's pretty small, but for this demonstration, I kind of want things to kind of pressurize really quickly and not sit there for like 4 minutes or 5 or 8 minutes while the compressor fills the tank completely. So we'll just make it a tiny little tank. And actually, my compressor is actually at a pretty low flow rate as well. We're going to study compressors much later, so don't worry about these numbers. Just set it to this value, and then it'll make the simulation work for us. There we go. And set your accumulator to this guy here, and this accumulator is this guy, this little tiny air tank. It's very small, 0.1 cubic feet. The accumulator pressure regulator is going to be set to 70 psi, which doesn't say here. Okay, moving forward. So what's going on is that this is kind of a step-by-step way to simulate it. I'm just going to show you how to simulate it, and we'll check out actually what's going on. So there are all these different types, kind of levels of simulation, so you can kind of really get a better understanding of what's going on, or you can simulate it yourself to fully understand how the backup system works. If anything, I'm just going to do it for you right now, and I will show you. So here we go. I've got the Automation Studio file going. What I'm going to do is I'm going to run it for you first, and then I'm going to show you how I got each individual part, where I got them from, and then you guys can build this. So let's simulate this guy. What I'm doing right now is this valve is closed, this valve is closed, and this valve is open. The air pressure from this compressor here is going through here, and it's going through this regulator, which is set to 70 psi. It's going through here, and it's filling up this accumulator. Now, the accumulator is full. I can pretty much do this, and I can even like remove this. This could be like a portable compressor, or I could actually just run a line from this guy, right, and put him over here. But maybe I have a little backup portable compressor. Might take a few minutes to go or whatever. It doesn't matter. What I'm going to do is I'm going to pressurize this guy, and I'm just going to leave it like that, like for a long time. I'm just going to leave it like that because it's my backup. I'm just like charging that extra backup battery, and I'm just sticking it in the cupboard in case I need it, kind of thing. So that's just going to sit there, and it's going to be charged as I'm using this the whole time. Could be like days or weeks or months or years. I might want to check it to make sure that it is pressurized. Kind of like how you might put a spare tire in your car and just check the pressure in your spare tire every once in a while to make sure there's still pressurized air in there. Here we go. And what's going on over here? Let's take a kind of look what's happening here. I have my pressure tank here. This is my compressor tank system, and what's happening is that my tank is actually small. It's just 0.5 cubic feet. It's a small tank. I've got my pressure regulator here. Anything after this pressure regulator has pressurized up to 80 psi, and we can see that there. Before, I've actually got my compressor here. My compressor is chugging along. It's going. Now it's actually going up and up and up and up and up and up and up. I don't have a control on here. I don't really at this point need to put control into that compressor because right now we're not really bothered with that. We're just really looking at, you know, how to focus on putting a backup power system. So there we go. I'm just running my compressor. It's just going and going and going and going. And I've got this really high pressure over here. It's now pressurized to its maximum 435 PSI. What I want to do is I want to run this. So I've got my pressure regulator here. I've got really high pressure on this side. I've got low pressure on this side. Anything past here is going to be 80 PSI. Now, because this shuttle valve is seeing a higher pressure on this side, then that 80 PSI is coming up here, and it's going to here, and it's going to here. If I open this, this 70 PSI will be seen here. Watch this. The 70 PSI is seen here, but that's still, it's not shuttling the valve. When it does shuttle, you see this little ball move over to this side. When this side gets higher than that side, the ball moves over. So what's going on is that this guy's 70 PSI. What I'm going to do is I'm going to shut that off because that's our backup. We don't want to have that there unless we really need it. So what's happening now is that I'm going to run this a few times. I'm just going to click on this. It'll go over. And I'm going to show you how to build this valve a little bit later too. So I'm going to click it again and it'll go back. So I know this guy is going back and forth and back and forth, and I am running this and everything seems to be running okay. Now this guy, if you notice, the pressure went down a little bit. That's because I'm using the air. If I press it really further, I'm just going to show you this for now. It's really cool. Maybe this will give you an idea of, like, when we get into compressors, why flow rate is so very important, why we actually bother calculating the required flow rate so that we can select the right compressor. I'm just going to run this a bunch of times. Watch the pressure on at the compressor. Or sorry, the pressure, what's going on is that this pressure here, this 380, it's going down a little bit. I'm going to press this. If I did this a whole bunch of times, we can see this is going down and down and down. That value is going down. I'm just going to do this for a while until it gets really low. Now we're getting below 80 PSI. We're getting below what the pressure regulator is set to. And you can see the pressure right here in this gauge over here. Right there, what's happening is that that's actually getting really low. It's supposed to be at 80. What's happening is that the compressor can't handle this much work. It can't handle the required flow rate. So we have to put a bigger compressor in there, but we'll do that. We'll figure out how to define what kind of compressor we need when we get to study compressors. I just thought it would be neat to kind of just show you that. So we'll just let this guy pressurize up, and this tank will start to fill. And on this side, as soon as we get 80 PSI on this side, 80 PSI is going to be on this side. Now, what I want to do is I want to simulate the compressor going down. So this guy is 80 PSI. It's going to stabilize and stay that way because my pressure regulator is doing that. But what I'm going to do is I'm going to open this up and simulate a failure. So right now, all of this air is venting out here. I'm losing air in here. We can see that the air to the right side of my pressure regulator is also dying as well. So if essentially what's going on is that all of the pressure is leaking through this guy, and there's no pressure. I've just lost everything, but I still need to open this hatch. It's a big heavy hatch. So what I'm going to do is I'm going to turn on my backup supply. So I'm going to turn this guy on, and I've got air coming in here. Air is available. What I want to do is I want to lift this up. So when I lift it, watch this. And by the way, did you see what happened? This was 70. It went down here and it went into here and into here. What's going on is that this guy is one big accumulator. This is an accumulator and that's an accumulator. So what just happened was the air that was in here got shared in between here and here. Okay, so now that means my pressure went low. So I've got 49 PSI left. Is that enough to lift it? Well, you've got to do your designing. You've got to figure out how much force you need, how large your cylinder is, and then you've got to say, okay, well, hopefully that's enough. That gives me force to pick it up. If anything, it's going to help me physically lift it if I need the extra help to lift the heavy latch. There you go. So it's gone up. Now the pressure is really low. It's gone down to 28. Let me lower it again. Okay, now the pressure is really low. It's like 13. I don't think it's going to go up all the way again. It's just going up. It's probably not going to come down. there's just a ridiculous amount of pressure. So because the pressure was so low, it actually lifted because there's no actual heavy weight on here. I can actually simulate a heavy weight on here in Automation Studio. I should have done that. But what's going on is that I've got no pressure left. Nothing's going on anymore. But that was okay. I was able to lift it one time. So let's just do that one more time. What I'm going to do is I'm going to turn this off. I'm going to go and I'm going to stop this leak. This guy's going to pressurize. I'm going to wait till this is 80 psi. Well, till that's 80 psi. And then on this side, it'll be 80 psi. And then I'm going to let this, I'm going to run this a few more times. Maybe I'll let this go up to 120 psi. And then I'm going to run this a couple more times. And we'll see. Okay, good. We're getting there. 80 psi. Nice. 80 psi. That guy's going up and up and up and up and up and up. Okay, good. So I'm going to run this now. Okay, this goes up and this goes down. I'm running it. It's not a problem. We can see that this pressure is compromised a little bit. So we may actually want to get a different compressor if we're going to run it this quickly. But for now, we're just saying, okay, it's working. Now, what I'm going to do is I'm going to simulate a failure. Bam. Okay, now my pressure's gone down. I'm losing everything. Actually, there's pressurized air in here. This is like an accumulator. There's pressurized air in here, and we can see it's venting. Now, there's the air in here is now at atmospheric pressure. I'm going to do this. I'm going to turn this on, and that air is going to come up in here, up in here, up in here, and it's going to fill this back up and pressurize that area. Ready? Here we go. I've just opened this guy up. Wait a second. Oh, I've got no pressure in here. Right, I forgot to fill this again. So I'm going to make sure that this guy is closed. I'm going to fill this. Right, this is good because you have to simulate this yourself. I'm going to fill this up, make sure it's full because, you know, I just used it. So I better fill it up again. There we go. Now, I'm going to open this up. I'm going to have this coming in here. This is going to go low. This is going to go low because all that extra pressurized air went from one volume and shared into these two volumes. So this is like a little accumulator. Now, I'm going to run it. Now, I've got 47 psi. That's going to help me lift it. It's a heavy weight. It's going to go up there. Now, I've only got 26 psi left. I'm actually going to lose some of that, lowering it. Now, I've only got 12 or 11 psi left. And as soon as I start using that, it's just going to get low again. And it's going to raise, but essentially there's a big heavy weight on here, so it's not actually going to go up. So we can say that that's it. We got one try out of it. So there you go. That's essentially what's going on here. We have this option of running this cylinder at least once to help us open that latch. Now I'm going to shut this down and I'm going to show you where I got these components. First of all, I'm just going to kill this guy and let's make him again. I'm going to go over to pneumatic. I'm going to go over to actuators. No, I'm going to go to directional control valves. I'm going to go down to my 5.2, and what I want to do is I want to grab a valve that's got two things on the right side. Two things on the right side. There we go. That's got two things on the right side. So I'm just going to put that in there. Perfect. I got to go in there. No, I'm just going to undo that because I didn't put it in the right place. Got to get it just bang on. Perfect. Now I'm going to click on this guy. I'm going to go to my builder, technical specifications. What I want to do is I want to turn this into a detent. I want to turn this into a detent, and my detent, what it does is it actually keeps the lever wherever I put it. Now I've just changed this. I'm going to change that to a lever, and I'm going to get rid of this guy, and I'm going to go over here and I'm going to put a spring on here. Whoops, that's an adjustable spring. I just want a normal spring. There you go. So now I've just made that valve. I'm just going to say okay, and I'm going to close it, and there you go. If I didn't have that spring, this lever wouldn't go back. Let me just simulate this. Okay, there's my lever. Now I'm going to click this and the lever will go back. If I didn't have that spring, if I got rid of this spring, and I just said gone, just gone, dude, then, oh no, the spring didn't go away. If I got rid of that spring, delete, please and thank you, yep. Then what's going to happen is that my lever won't actually return. I can go there. I get rid of my detent as well, but it won't go back. Oh, it did go back. There you go. Doesn't quite click properly, but I think it's because the detent is gone as well. That detent really should be there, so it's difficult to bring it back. It's not really working very well, so you want to put that spring in there. Now, where do you find all these other components? Well, you just search around for them and look for them, but essentially what I'm going to do is I'm going to go compressors. I'm going to grab this compressor and I'm going to put it in there. Now click on this guy and you can see all of these settings. What I'm going to do is I'm going to click on this guy and show you what I did over here. And let's also take a look at the lab sheet. So I've got my lab sheet here. Compressor 1 is set to 600 RPM. So I've set that to 600 RPM. And also it's 15 cubic inches per revolution. That's what you got to set it to. So there you go. Now let's take a look at the tank. I'm going to click on this guy and we can see the volume of the tank is 0.5 cubic feet. And you can do the same for these guys. And the specifications for those are on the lab as well. And set the regulators. To find that regulator, you go down here and you say, where are the regulators? What do I do? Flow control, pressure, pressure control. Sweet, because regulators, that's what they do. At the pressure reducing valves, and here we go. That is my pressure regulator. So I can put one of these in here. Pressure reducing valve, that's what it's called in Automation Studio, but we also call it a pressure regulator. So you can drop that in, and these guys, you know what? I'm gonna leave you to search around to find these guys. The shuttle valve, really cool. So we're gonna look at flow valves and we're going to look at others, and we go for shuttle valve and we go there. So there you go. There's your shuttle valve. You don't have to make any settings for that. So I think you can build all of this. Oh, this guy's important. Where do we find a pilot controlled check valve? Go into flow, go down to here, non-return valves, and there you go. There you go. So now you've got all the components. You know where they all are. Build this thing. What I want you guys to do is I want you to label all of this stuff properly, like I had here. All of these things, put all of these labels on. Plus, because it's a proper circuit, I want you to label all of the ports on here as well. And it's also good to put a label on to, I've got mine labeled at 80 PSI and then set to 70 PSI. You should do that as well. So there you go. That's the lab. You know what it's all about. You guys know how to build this. You know where the components are anyway. Put it all together. I would suggest that you grab valves. You grab another one of your circuits that you've built with all of the valve numbers already put on them and some text there already. And just grab that and open it up. Save it as this and start deleting stuff that you don't need and add all of this. There you go. Have fun. Okay, bye.